This is a lesson for 6-7, which is transformation combinations. You're not just going to be doing one thing today. You're going to be doing two different transformations to the same picture. So you might do like a reflection and then a rotation, or you might do a dilation, then a translation. There are two different types of questions. The two different types of questions are you have to be able to recognize it. You'll be given the three pictures on the screen, and you have to say what is going on, whether it's a rotation, then a dilation, or a reflection, then a rotation, etc. And then you're also going to have to draw them. So let's just go over, let's spend a few minutes and go over what each of these are and what they look like. You also have to make sure that when you're writing a description of them, that you are specific in your transformation names. You can't just say a reflection, all right? You can't just say a rotation. You can't just say a translation. You can't just say a dilation. You need to be specific afterwards. So let's talk about what they are. So in a reflection, first of all, remember that a reflection is a mirror opposite image. It is that flipped opposite mirror image. What you have to be specific with is you have to specifically say whether it is over the x-axis or over the y-axis. You can't just say a reflection. You have to say whether it's over the x or over the y. For a rotation, remember, turns a picture. Now, with a rotation, there are three different things that it could be. You can't just say a rotation. You have to say a rotation of 90 degrees clockwise, or 180 degrees, or 90 degrees counterclockwise. You can't just say a rotation. You have to specifically say how many degrees and which way it's turning. For a translation, remember the S&L in translation stands for a slide. It slides a picture from one location to another location. You specifically have to say how many places left or right, so left or right and then a number, and how many places up or down and then a number. You can't just say a translation. For a dilation makes a picture bigger or smaller. For a dilation, you have to specifically say of what number, so what you are multiplying by. So this is very, very important. For a reflection, you have to say over the x-axis or over the y-axis. For a rotation, you have to say 90 degrees clockwise, 180 degrees, or 90 degrees counterclockwise. For a translation, you have to say how many places left or right, how many places up or down. And then for a dilation, you have to say of how many. So what your scale factor is, what you are multiplying by. So let's take a look at what these pictures actually look like. So there's just one thing going on in each of these pictures. We're not to the two yet. I just want to remind you of what they look like. So when we take a look at this first one, remember that you are always going from the letter to the same letter prime. So if I'm going from this triangle, this is my first triangle, this is my new triangle, because this is the one without the primes to the one with the primes. What is going on here? Well, is the picture being turned? No, I can see that A, B, and C are all in the same place. Is it getting bigger or smaller? No, it's not. Is it a reflection? Is it that mirror opposite image? No, this one is actually a translation. Now, when you say a translation, you can't just say a translation. You have to say how many left or right, how many up or down. Remember, we talked about that right here. All right, we have to say how many left or right, how many up or down. So how do you get from A to A prime? We're going 1, 2, 3, 3 places to the right. So we're going right 3. And then we're going down 1, 2, 3, 4, 5, 6, 7. So right 3, down 7. In the next one. So taking a look at this next one, it is a flipped opposite mirror image. It's being flipped over the x-axis. If I folded up my paper, those two triangles will match up perfectly. So therefore, this is a reflection. Now, you can't just say a reflection. You have to say where this line of symmetry is. So it is a reflection over the x-axis. In this next one, this one is clearly being turned. All right, since it's being turned, this is a rotation. Now, remember the little clue when we talked about rotations. If it moves 1 quadrant, it's going to be 90 degrees. If it moves 2 quadrants, it's going to be 180 degrees. Notice that this moves 1, 2 quadrants. So it is a rotation of 180 degrees. For 180, we don't say clockwise or counterclockwise because they would both end up in the same place. And then this one, the triangle is clearly getting bigger or smaller. So it is a dilation. Now, when you go to figure out the dilation, I would just choose a point because you have to say what the scale factor is. I would choose a point like B and B prime. B is really the point 1, 0, where B prime is really the point 3, 0. Remember, the scale factor is what you multiply by. Well, what do I have to multiply 1 by to get to 3? 1 times 3 is 3. So this would be a dilation of 3. It's whatever you multiply by. In the next ones. So again, we're doing the same thing. We're just trying to recognize what is going on. To get from F to F prime, we're going 1, 2, 3, 4 places to the right and 1 down. So this is a translation of right 4 and down 1. Again, you have to be specific. You have to say how many left or right, how many up or down. Here in this one is a reflection. It's that flipped opposite mirror image. So this is a reflection over the x-axis. In this one is being turned. All right, we are only turning it 1 quadrant. All right, we're going this way. We're turning it 1 quadrant. So this is a rotation. Since we're only going 1 quadrant, it would be 90 degrees, but then you got to say clockwise or counterclockwise. Remember, clockwise goes around like the hands of a clock. Counterclockwise is backwards clock. So this is clearly turning this way. This would go from like 8 o'clock to 7 o'clock to 6 o'clock to 5 o'clock. So this is counterclockwise. And then in this one is a reflection again. This time it's that flipped opposite mirror image, but this time it is over the y-axis. Our line of symmetry goes up and down right here. This is the y-axis. So again, you have to be specific. Let's try one more set before we get into the actual types of problems that you're going to have today. In this one, the 4-sided shape here is getting bigger or smaller. Therefore, it is a dilation. How much bigger or smaller is it getting? Well, choose a point. I like choosing positive letters. So if I take a look at Q and Q prime, I take a look at Q and Q prime. Q is 1, 2, 3, 4, 4, over 4 up to 2. Excuse me. And Q prime is over to 2 up to 1. So how did I get from 4 to 2? How do I get from 2 to 1? Because you're going from Q to Q prime. Well, 2 is half of 4. 1 is half of 2. So this is really a dilation of 1/2. If you wanted to say 0.5, that would be fine as well. In this one, all that this shape is doing is sliding to the right 1 and then up 1. So it is a translation because it's sliding. and we're going right 1, up 1. In this one, the picture is getting bigger or smaller again. Anytime it gets bigger or smaller, it has to be a dilation. But then you have to say what you are multiplying by. This one, if I look at A and I look at A prime, A is 2, 1, and A prime is 4, 2. Well, notice in this one, I'm going from A to A prime. I'm going from 2 to 4. So this is a dilation of 2. That's what we're multiplying by. This one is being turned. So this is a rotation. And we are going 1 quadrant, 2 quadrants. Since we're moving 2 quadrants, it is of 180 degrees. So that was just a little reminder of what you were doing. Now, what are you going to have to do on today's problems? It says draw the image of the figure based on the sequence of transformations. Label the first image ABC, A prime, B prime, C prime, and the second one A double prime, B double prime, and C double prime. All right, those 2 little apostrophes are pronounced as double prime. You must follow this order. So the first thing that it says to do is a dilation of 3. Then it says to do a reflection over the y-axis, or sorry, over the x-axis. So we're going to take our initial shape. This one is going to be a dilation of 3. Then, based off of that shape, you're going to do the reflection over the x-axis. You can't just pick and choose. You have to do it in the order that it says. So the first thing that we want to do to this shape is a dilation of 3. Well, I know that when I go and do a dilation, I need the coordinates. So I'm going to write down my original coordinates for A, B, and C. My original coordinates are 0, 2 for A, 2, 2 for B, and 2, 0 for C. This is A, this is B, this is C. So when I go to do my dilation of 3, remember that this means that I want to multiply by 3. So if I multiply all this stuff by 3, I would have 0, 6, I would have 6, 6, and I would have 6, 0. That is going to be my A prime, my B prime, and my C prime. So now I'm going to go and graph it. 0, 6. 0, 6 is right here. That's A prime. 6, 6. Over to 6, up to 6. That's B prime. And 6, 0 is right here. That is C prime. Here is my new primed picture. So I did that. Now, when you go to do your double prime, you have to do the reflection over the x-axis using the single prime picture. We're done with this picture now, all right? We're done with that original triangle. So I'm not looking at that triangle at all. Now I'm looking at the primed picture. So I need to do the reflection over the x-axis. Well, reflection is that mirror opposite image. So there's my mirror. A prime is 1, 2, 3, 4, 5, 6 places to the mirror. 1, 2, 3, 4, 5, 6 places away. This is A double prime. B is 1, 2, 3, 4, 5, 6 places to the mirror. 1, 2, 3, 4, 5, 6 places away. This is B double prime. C double prime, C prime is right on the mirror, so it's 0 places to it, 0 places away from it. C double prime is actually in that same exact spot as C prime. It happens sometimes when it's right on the mirror. So there is my new shape. So this was our original shape. This was our second shape, and then the third shape is based on the second shape. So that was the third one. So we went from here to here to here. We're doing a dilation of 3, then a reflection over the x-axis. So let's try another one. In this one, it says do a rotation of 90 degrees and then do a translation of left 1, down 2. So if I go to do a rotation of 90 degrees, first thing that I want to do is turn my paper 90 degrees clockwise. So there's 90 degrees clockwise. And I want to know where A prime, B prime, and C prime are going to be. Remember that when you turn your axes, the numbers are no longer correct. A looks like it's at 3, 1. It's not at 3, 1. We're going over to 3, down to -1. Anytime that you go down, down is always negative. B prime, over to 3, down to 3, but it's not 3. Anytime we go down, down is negative. So this is 3, -3. And then C, over to 1, down to 2, but it's not over to 1, down to 2. It's over to 1, down to -2. So now I'm going to turn my paper back to normal. So turn my paper back to normal like this. And I'm going to graph my new shape. So 3, -1, over to 3, down to -1. This is A prime. 3, -3, over to 3, down to -3. This is B prime. 1, -2, over to 1, down to -2. This is C prime. Here's my new shape. So I did the first thing. I did the rotation of 90 degrees clockwise. Now I want to do a translation of left 1, down 1. I'm not using this shape. I have to use my prime shape to do my double prime shape. So when we go to do this, we're looking at the red one now. We want to go left 1, down 2. So starting at A prime, left 1, down 2. Here's my new A double prime. Starting at B, left 1, down 2. Here's my new B double prime. And starting at C prime, left 1, down 2. Here's my new C double prime. And there's my 3 shapes. So this was my original shape. This was my new shape, my single primed, and this was my double prime shape. So that's one type of question where they give you the directions and you need to draw and label the new shapes. Now, the other type of question, they'll have the 3 shapes already there for you. What you need to do is you need to say what the sequence is. Now, again, notice what the sequences look like. All right, this is what you're going to be writing. All right, notice it's very specific. It just doesn't say rotation, then a translation. It says rotation 90 degrees clockwise, then translation left 1, down 2. Or you're going to be writing something like this. Dilation of 3, then a reflection over the x-axis. Again, you have to be specific. I think it helps to number these, all right? Remember, this is your first one. Why is this your first shape? This is your first shape because it doesn't have any primes. Then we go to the single prime, then we go to the double prime. So what are we doing here? How do we get from 1 to 2? Well, I can see that I'm doing a translation because I'm just sliding it. But again, you can't just say translation. You have to say how many left or right, how many up or down. So to get from A to A prime, I'm going 1, 2, 3, 4 to the right. And then I'm going 1, 2, 3, 4, 5, 6 up. So that was my first thing. That got me from the blue triangle to the red triangle. Then, all right, now I got to get to the purple triangle. So how do I get from my single prime to my double prime? Well, I can see that it looks like a flipped opposite mirror image. Here's my mirror. All right, if I folded it over, triangle 2 and 3 would match up perfectly. So then we are doing a reflection because it's that mirror opposite image. And you have to say over the X or over the Y. This is clearly over the Y axis. So there's my rule. Take a look at one more. So again, I think it helps to number these triangles. This is my original triangle. Then I go to the red one, then I go to the purple one. So looking at the blue to the red, right, I can see that my triangle is being turned. Since my triangle is being turned, it has to be a rotation. Now you can't just say a rotation, you have to say how many degrees and which way. Well, if I go from triangle 1 to triangle 2, notice that I went through 1 quadrant, 2 quadrants. So it's a rotation of 180 degrees. Then now I got to get to triangle number 3. Well, I can see that my triangle is getting smaller, so then it would be a dilation. And then you have to say of how much. Well, one of the ways that you could sort of cheat the system, instead of doing the coordinates, which you could do, all right, instead of doing the coordinates, look and see how tall the shape is. Our original one was 4 units tall. Our new one is 2 units tall. Our original was 3 wide. Our new one is 1.5 wide. So it has to be a dilation of 1/2 because it's half the size of the original. Now you could use the coordinates as well, right? If I go and use the coordinates, I'm going to use C prime and C double prime. C prime is -4, -2, and C double prime is -2, -1. Again, to get from your C primes to your C double prime, it's half. You're multiplying by half, so it has to be 1/2. Again, you have to make sure that you are specific in how you are labeling these. You have to say reflection over the X or Y axis, rotation of 90 degrees clockwise, 180 or 90 degrees counterclockwise, translation, how many left or right, how many up or down, and then a dilation of how many, what are you multiplying?